Fender System. Fender System is an act as elastic buffer devices that are used to slow ships down and prevent damage to the ship or dock structure in the mooring process. They absorb the kinetic energy of berthing vessel and thus prevent damage to the vessel or the berthing structure. Two major categories of fender system. First is fixed fenders. These are mounted to the berth structure and composed of buckling fenders such as cell fenders, V-type fenders, and non-buckling fenders such as cylindrical fenders. Next is the floating fenders. These are placed between the berth structure and ship and include pneumatic fenders and foam-filled fenders. Installation of fender. First, if the contractor must ensure that the face of concrete to support the fender shall be sufficiently wide and truly flat and vertical to provide sound-bearing surface to the fender. Second is during the placement of the fenders, slinging and hoisting of the rubber section is permissible, but caution was required to avoid tearing of the rubber. The use of canvas sling or other protective device can be adopted. Third, the use of stainless steel cut washer under attachment bolts are required to prevent cutting and tearing the rubber. Fourth, all inserts shall be incorporated in the fender elements during molding and lamination, and the like is not be permitted. Fifth, the fixings shall be accurately cast into the concrete. A template or other device will be used for this purpose. Sixth, fixings and fittings must be protected against the damage until the fenders are fixed. Details of fender. The anchor bolt attaches the fender to wharf. Tension chain restrains fender body under low impact condition. Shear chain restrains shear deflection of fender. Weight chain supports frontal frame. Frontal frame protects hull of vessel by reducing contact pressure. Frontal pad reduces friction coefficient to protect ship's hull. U-anchor attaches chain to wharf. Assuming that the ship hits the dock, the fender, which is installed on the dock, is to absorb an energy which equals 1/2 of E, as the other half is assumed to be absorbed by the water and the ship. E is the kinetic energy, where E equals 1/2 multiplied by W over G multiplied by V squared. The W is the displaced weight of the ship, and the V is the velocity of the ship normal to the dock. As the work done by the pier is 1/2 of F multiplied by D, then 1/2 of E equals 1/2 of F multiplied by D, where F is the force to be resisted and the D distance through which the force moved. Problem. A dock is protected by a wood fender system. A ship of displaced weight of 14,000 long tons, which is 14,254,545.45 kilograms, is to dock with a 0.15 feet per second with a maximum speed normal to the dock. Compute the energy that is expected to be absorbed by the fender system from impact by the docking ship. Solution. We have the formula E equals 1/2 multiplied by W over G multiplied by V squared, which is equal to 1/2 times the W, which is 14,254,545.45 kilograms, divided by the gravity, which is 9.8 meters per second square, multiplied by the velocity, which is 0.04573170732 meters per second squared, which has an answer of 1,521.01202221 kilograms per meter, or 14,905.9002 newtons per meter. E equals 1/2 mv squared, 1/2 times 14,254,545.45 kilograms multiplied by 0.04573170732 meters per second squared, which has an answer of 14,905.9002 Newton per meter. The use over M over G in the expression for the E facilitated clear cancellation of terms to obviously result to kilograms per meter, unless an acceleration due to gravity, which is G, is multiplied to it so that the Newton meter unit will appear. The use of M over G or the use of W over G in the expression for the energy of impact is as per convince which either can offer. The E equals 1/2 mv squared is theoretically correct, and the ships in the United States got displaced weights which are expressed in tons, which is an English unit for the W. In the Philippines, the English units are converted to the metric equivalent, where the energy is absorbed by the Fender system is 1/2 of E equals 7,452.95 Newton per meter. And that's it for Fender system.